Let's start with learning how to do operations with vectors, right? First, let's understand what vectors are. So, vectors first. So, what are vectors? Vectors, simple terms, is just a list of numbers. So, we have worked with Python list, right? So, in machine learning, in order to work with a list of numbers, we actually just simple call them vectors, right? So, a vector, it is a list of numbers basically. So if you forgot what a list is, let me say, so let me do pi list. Pi list is equal to, yes, something like this, 1 comma 2 comma 3. So this is a list of numbers, right? So in normal Python this is a list, but then to call this, qualify this as a vector, right, we need to use a special library in Python in machine learning that's going to help us, and that particular library is going to be the NumPy, numerical operations in Python. So we need to import NumPy as NP, so that the NP is just the abbreviation of this. So we are using this NumPy library, but then instead of writing NumPy every time, we just be doing NP so that it will be easier for us to operate with. Now, so we know a list in Python. We usually use this in a Python, but then in machine learning, we want to actually basically call them vectors, right? A list of numbers is called vectors in machine learning. So in machine learning, this list of numbers called vectors can be formed from various stuff, right? It can be formed from various ways. One way is to form the vector from a Python list. So if you have a list already, you can create um, a, a, a NumPy vector from it. So so let me say creating creating a vector from a Python list, or you can just say a list, right? So the very first step is to be able to do this. How do we create a NumPy from this one? So we, to do that, we say let's call it ml vector, or let me just call it vector. Vector is equal to, so we just call the np dot array. Np dot array is something that you need to have there, right? And inside this, you need to pass the Python list that you have, right? So inside the np.array, we are passing the list that we have now. So this is what we have. We are passing this to this, or you can quickly directly just put the list inside and do 1 comma 2 comma 3, for example. But if you have the list already and the list is in a variable Python list, you can just quickly just write this, right? So by list, there won't be much difference. So let's print this. So we say print Python list, right? So let me say pi list. I'm printing the pi list. Then print vector. So that is going to be vector. So if you run this, pi list is not defined. Okay. I have an error here because this is capital L. This is also capital L. The name here is pi capital L list. So my bad. So it runs. So right now we can see something. So the Python list is printed as 1 2 3, right? You see it's 1 comma 2 comma 3 in the Python list, but here as a vector it's now differentiated into 1, there's no comma, 2 and 3. That's one key difference that you see here, for example, right? That's how to create a vector. So it's we are going to see why we need to work with vector instead of Python list in this. Doing operations with Python list directly to handle a large number of data is very difficult. But in a vector form, it's easier to do operations to save time and for performance cases, right? So in machine learning, we usually use the NumPy array. So NumPy array to make the list. So one way of doing that is to be able to create the list, the Python array or vector from the list. So let's do key operations basically. So I'm going to comment these guys out, right? so that we don't print them, but we rather work with. So we are now focusing on the key operations with to know the difference, right? Let's say we want to add um 2. Let's say we want to add 2, number 2 to each element. We want to add the number 2 to each element in the list, right? Want to add an element 2. So what we have to do is that when we add 2, you need to have this one will become 3, this one will become 4, this one will become 5. We want to add 2 to each element. So we are going to do that with Python list, and then we are going to do that with vectors to see the difference, right? So what we are going to do is first, because of errors and stuff, I'm going to put in a try. So in try, so I'm going to new list is equal to, so going to do py list plus 2. So what I'm trying to do, I want to add 2 to every element, right? Except, so type error as e. So if there's an error, we are going to print the error. So let me say error e. Okay, so don't worry about this. You can do it directly. Now let me run this. You see, we cannot concatenate or add these guys to that. So it's as if we are doing concatenation of a list to a list, right? We are adding this is of data type list, and this is of data type int. So, right? You can, and the plus is for addition or concatenation if they are strings. You can be adding different data types together if they are different data types. Especially this is a list data type, and this one is an integer or a numeric data type. So that addition cannot be done. Okay, so how we could run this thing now? How is this thing going to run with list, a vector? Let's work with vector now. So with vector, you don't need to do all those plenty things. All you have to do is just do new vector equals to, so it's going to be vector plus 2. Let me print new vector. So yeah, let me print the new vector. So you see what happens with this line of code. Every element in the list or in the vector has been upgraded. So this plus 2 is done to each element, right? Doing this is called element wise operation, right? So you can directly, if you have a list or you have an array, if you have an array, right, or you have a vector, with vectors, when you are adding something, the thing is added individually to each element, right, to become 3, 4, 5. That's what happened with, right, which cannot be, that's what happened with vectors, which cannot be done straight with a list. So this is one of the reasons. So the same thing applies to multiplication, squaring an element and all that. So right, so let me say, let's square each element in the list. So it's going to be star star before the number, right? If you square every element, so that's going to be, because the vector is 1, 2, 3, right? It's 1, 2, 3, so it become 1 squared is 1, 2 squared is 4, 3 squared is 9. So we are squaring it directly. You cannot do this when you are using a list directly. So the operation is faster, quicker, and very good for stuff. So in order to actually, we could actually run it ourselves, right? To work with a list directly, right? We can still do this with a list, but it's going to give spend cost us operations and performance. So what I mean by this is that, let me say new list equals to, so we are going to add a new list. We are going to say x plus 2, for example, for x in list. That's the name, py list. Then we now go and do print new list, right? So I'm going to call it new list. So you run this, you can see that we have added 3. So let me do addition here as well. So if you do the addition, you have 3, 4, 5 in the vector and 3, 4, 5 comma separated by comma in the list as well. So here we are doing a for loop operations and it's going to be taking much time. So what if you have a very large number of elements in the list, right? So if you use this, the vector way is easier to operate. So we now know how to create a list from a vector. We know how to create a vector from a list. So now let's now look at the other ways of creating a vector. Let's say you just want to create a vector, you don't know what elements are going to be inside, but we know that a vector is just a list of numbers, right? It's going to be containing numbers. So one way of is doing pre-allocation, right? Where we have, let me comment this thing out so that it doesn't interfere with what we are going to type here. So we have the vector and we have the list here. So okay, so now let's go deeper and say other ways of creating a vector, right? So the very first thing is we are going to create with zeros, right? So I'm going to say, so what we have to do is that we have a vector, we have to create a vector that's going to contain 3 elements, right? So at the start, we don't know the numbers that will be inside, but we just want something, a vector that will be there. So at the beginning, we can decide to populate with any number for now, right? You can pre-allocate it. So read it at the start. You don't know what's going to be inside, but then you want to have a vector, right? That will contain placeholder numbers, or maybe those are the numbers that you want to use. So one way is to fill it, create a list, create a vector, and fill it with 0 at the beginning. That's what we call pre-allocation. Let's fill it with only zeros. So let me call it 0 vector, 0 underscore vector equals to, so np dot array, np dot zero, sorry, zeros. So we are going to do 3 elements here. So let me print this thing out. Print 0 vector 0 underscore vector. So we are just basically calling that. You see what happened? There is the list for us. 0 vector is now a vector, is a vector for us, and it pre-filled with 0 0 0 0 3 because we said 3. So this particular way is going to be returned as a vector, but that vector is going to be filled with 0. If you have a list, that's why we're doing dot array, right? Dot array to put in the list, right? But if you are just filling it with 0, you can just do mp dot zeros, right? Zeros. So you don't forget the s at the end, zeros. So we are filling it with zeros. Okay. What's the another thing that we can do? We can also pre-allocate with ones, not just zeros. So let me call it ones vector equals to mp dot ones 3, right? So let me print this and say ones vector. So you're going to one, that's called vector. That's the name there. Okay, you run this. So you see that this one is filled with only this. Let me comment this thing out so that it doesn't interfere as well. So this is for zeros, right? Or let me just keep them so it run. So for the ones vector, we can see that it is pre-allocated filled with 1. So that's it. We just want a vector that will be filled with only 1. So basically, that's easier. So first one is to be able to create it from the list, and then I think I need to print the one that I created from a list, right? So let me do, where is it? It's here. So vector from a list. Yeah, vector from a list. From a list. Let me print it. Let me add it to the this thing. So we have vector from a list, which is this one. We have the 0 vector that we have. We have the ones vector as well. Okay, that's not all. Let's look at another thing. We want to now not just fill it with ones or zeros, but we want to fill it with numbers like 1 2 3 4 5, right? Numbers in a series. We want to fill it with series numbers, right? So is to one way of doing it is to use the arrange. we are going to give it a range of numbers to fill it with. So I'm going to do pre-allocate from a range, right? So we are going to say range underscore vector equals to np dot a range, right? We are going to give it a range. We are going to start from 2 and going to 8, for example. So we are going to fill from 2 to 8. The thing is that then this particular thing, there is going to be only starting from 2 and stop at 7. It will not go to 8. The last number is not included. The last number, the last digit here, the back digit here is excluded. So this one, like from a range. So this one, for example, from the range is going to be the range is 2 to 7. 2 to 7, basically to 7. So the 8 itself is not inside. The last number that I put here is not inside. So if I put 7 here, you will not see it. First, let's run the 8 one first. So it's going to be print is vector range vector. So range underscore vector. Okay. So if I run this, you see there are 2, 3, 4, 5, 6, 7, because I'm saying from 2 to 8, right? But it's actually filling up to 7. If I change this to 7, meaning that it's from 2 to 6. So you need to keep in mind that the last number here is exclusive. It's exclusive. 2, 3, 4, 5, 6, right? 2 to 7. So if you want to 2 to 7, meaning that you are basically 2 to 8, and then you run it, you should be able to do 2 to 7. So that's how the range is created from that. What if you want most create a series of numbers, right, that are separated by for example, let me give an example to illustrate what I mean. So what I have been pre-allocating within a tight range, for example, like within a tight range. Let's say we want to do between 0 and 1. We want to have some thousand numbers from 0 and 1 and fill it with the list inside the vector to create a vector from it. So basically, let me say um um short underscore range, right, equals to, so what we do, np dot linspace. So over here we are going to also fill it with 0. We want a number between 0 and 1, right? But how many number do we want between that? We just want, let's say 5, for example. Let me print this. Short range numbers, right? So I'm going to do short range, run this. So now what's happening between 0 and 1? We are printing 0. This is 1, 2, 3, 4, 5. There are 5 numbers in total in this vector. 5 numbers in total in this vector. The first one is 0. The second one is 0 0.25, 0 0.5, 0 0.75, and 1. So from 0 to 1, we want to get 5 numbers that are evenly spaced. The space between them is even. So I can even do 6. If I do 6 numbers, I run this, you can see 0, 0 0.2, 0 0.4, 0 0.6, 0 0.8, and 1. So the numbers are evenly spaced, right? But they are in a touch range of 0, 0 to 1, right? 0 to 1. But over there, in them, we want 6 numbers that are evenly spaced. We want to have 6 numbers that are evenly spaced. That's what the linspace also gets you. So it allows you to get any amount of number that you want. Let me do 10. Definitely there will be something like this, right? Yeah, it's getting longer, right? Between 0 and 1, you can do 0 and 2, right? 0 and 2, for example. So you see 0 0.2, it will start from 0 up to 2, but before you get to 2, you need to make sure that it's the numbers that are between them are evenly spaced. So try its best to give you a very evenly spaced variable. Yeah, so that's how to use create a vector either from the list space, from a range that you have, from ones, from zeros, or from a list. That's the popular one popular one from that we'll be using mostly. But for pre-allocation, right, you can fill it with zeros, you can fill it with ones, or any other thing that you need.